This video will illustrate how JEOL element library files can be used to quantify Auger data from a JEOL instrument. We're going to load a depth profile and use this to illustrate the steps leading to quantification using a peak-to-peak measurement and the appropriate RSF tables from the JEOL instrument. So if we're going to use peak-to-peak, then the first thing we need to do is differentiate these data. So we'll use a Savitzky-Golay 5-point quadratic differentiation of the data and then propagate this processing operation to all of these VAMAS blocks that are in the profile. So having differentiated these data, we'll be able to estimate a peak-to-peak intensity, and so we need to load a peak-to-peak element library. And the peak-to-peak element library, if we browse, we can find a directory that contains these JEOL element libraries, and although we could have compiled them as we have done here into a single element library, we can select an individual one and load it. So this is what it looks like. It's a table of elements and sensitivity factors, and when we load it using the appropriate format, so if we just load it using the wrong format, it will illustrate that you need to select the JEOL AES because these are JEOL AES files, and once loaded you can then start using these to quantify the spectra using quantification regions. So we'll set a background type of 0. This is really cosmetic so that we can see a very simple region that's associated with these data. But the idea is that we're going to calculate the intensity based on the maximum and minimum height within the region. So what we're going to do is add a region to the titanium, carbon, oxygen and manganese spectra in the first row, and then we'll propagate these regions using the propagate and match option to the entire depth profile, where carbon regions will be copied to carbon regions, titanium to titanium, and so on, and so that we will end up with a profile that consists of a sequence of spectra, all of which will have quantification regions and the appropriate RSFs for the data type. So having performed this propagation operation, you can now see that all of these data have regions with appropriate sensitivity factors. And once we've got these, we can use the report spec page to generate a profile by selecting all of the VAMAS blocks in the right hand side, creating a table of regions, and then using the height report. And the height report will let us see how these elements vary as a function of etch time. I can just perform a few minor display operations here to allow the display of this profile in slightly different form. We have performed quantification using the JEOL RSFs.